any function. What? Domain of range. First question, always. What can I and what can't I do here? Okay? A rational, the parent function of a rational equation looks like this. So clearly something is weird, right? Now think about it. If you have x in the denominator, what should your concern be?
Or it can't be 0.
It can't end up being a 0. So you have to figure out which x would cause it. So for vertical asymptotes, okay, so to find vertical asymptotes, so we don't pronounce the P, set denominator to 0 and solve, go cannot equal 0 and then solve for x, so you'll get an x cannot equal a number. You'll get it immediately as a cannot equal. In a minute we'll practice it. For horizontal asymptotes, it's a little more complicated. When you have polynomials in the numerator and the denominator, you're going to have a, let's say x to the n plus dot 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 over, let's say b x to the m plus dot dot dot, okay? To know horizontal asymptotes, it's the leading terms that matter. So, if m is greater than n, so if the power on the bottom is greater than the power on the top, that means your horizontal asymptote is at y equals 0. That means the x-axis. Unless there's a vertical shift on the end. Okay? So if you have something and then it says plus 1, figure out this and then go plus 1 to it. Okay? If n is greater than m, there is no horizontal asymptote. Might have slant asymptote found by using long division. We'll talk about that if that comes up. And if n equals m, the horizontal asymptote is there at a over b. We take the coefficients, right? So if you had, for example, 3x squared over 4x squared, your horizontal asymptote would be at 3/4. Y equals 3/4, okay?
What does your note say in the parentheses?
1 second. Okay. Might have, sorry, because I'm writing lower, so my handwriting gets worse. So, okay, let's try to do this. That better? Yes. Because sometimes you can have a slant asymptote and your equation looks something like that. Okay? So how do you figure those out? You use long division. So the answer without the remainder is the equation of the line that is the slant asymptote. And we'll get to that. To graph, you need
Is this one where you can make a, I don't want to say imaginary, but like your own little axis to do your thing on?
Oh, yeah, and when you draw your asymptote,
Yeah.
it's the...
1 second,
but the
okay?
asymptotes.
Let me focus. That's what you need to graph, okay? So you must always know these things. All right, what was your question?
Isn't this the one where you like the axis of your function can be anywhere?
don't know what your, it could be in multiple ways, this is how you find it, okay? So let's start.
Can I ask a question?
Yes, sir.
On the left side, the second from the bottom, does it say no horizontal asymptote?
Yeah, no,
No,
No.
okay, thank you.
no, yeah, no HA.
No, it just.
If they are,
Looks like
if they are
RO.
exactly, if the top is bigger, let's say you have X squared over X, you're gonna get kind of a bloop, or you're gonna get a bloop. You're not gonna get an asymptote, okay? A horizontal asymptote.
What's the noise for an asymptote?
What's the what?
I don't know, I never, what's the sound of you crashing into a wall? That's the noise.
Boing.
No, boink is tangent. Boink is when you touch something and it's exactly one point.
Oh.
Don't know if it sound like hey, tangents.
But yeah, asymptote is crash. No, you never crash.
Yeah, there's no
Oh, yeah.
You never crash, so I guess the sound of
It's like a car screeching, yeah.
Yeah, car screeching.
Like a drifting car or something.
Car
It's like
getting closer to the edge of the road but never getting to it.
always getting closer but never
Always
getting
getting
there.
closer. That would be so
What page is
intense.
this on?
124.
It's like
Did
in a
everyone
car,
write the
always
notes?
getting closer to crashing
Yeah.
but never crashing.
Yes, that would drive me
No,
crazy.
we're on page 124.
He's
Nick, 124. Guys, attention please. Okay, so we need the vertical asymptote. Where is it? You take the denominator, x minus 2, and you go x minus 2 cannot equal 0. That's my biggest concern. So that means x cannot equal 2. So where's your vertical asymptote? At 2. Okay? So vertical asymptote is x equals 2. Right? That's a vertical line. So if I had to graph this, that's the first thing I draw. Oh, that could be our sound for asymptotes. A dash line. Got no little Spanish for it.
Roll your R's.
Okay. However, when we do the horizontal, what do you notice? The power on the bottom is bigger than the top. There's actually no x on the top. So normally it should be at 0, but what happened here? A vertical shift. So a horizontal asymptote is at y equals 1 because of that. Okay. Let's take a look at number 6. What do you notice about the powers? Same. So what do we do when they're the same? Make a decimal. Then my vertical, I always take the denominator, set it to 0, and figure out what is that x that's going to be a problem. You know what? Don't even put the not equal 0. You'll get the x. You'll get the line if you do equals. I just want you to remember what things mean. You are looking for the one value that shouldn't work for you, where you should be drawing. Okay? All right. Okay, I have time here. No. You give me a signal, okay? Sure. Okay. So now, if you have to graph and state the domain and range, let's pick a graph here. Let me do number 12 with you, just because it has that